prehistoric Roomba has been quietly saving human lives for decades, but you've probably never even thanked it. So today I want to tell you about horseshoe crabs, which are actually a group of species that are categorized as living fossils. This doesn't mean that they are primitive, it just means that they've been around for a very long time, relatively unchanged because they're not experiencing strong evolutionary pressures. Put a more direct way, they are good at living and surviving in the form that they are currently in, so there's no strong pressure for biological change on a large scale. Contrary to what you might think, they are not less evolved than humans. Any species on the planet today is part of a lineage that, if you trace it all the way back to the origin of life, has been evolving for the same amount of time as any other lineage on the planet today. Horseshoe crabs have been around a long time, about 450 million years. That means they predate the dinosaurs. That's impressive, but they are by no means the only living fossils that we know of. Some other cool ones are the coelacanth, which has been around for about 66 million years, the goblin shark, which has been around for about 125 million years, and the tree called the ginkgo biloba, which has been around for about 270 million years. Horseshoe crabs are unique in a number of ways, like the way that they glow under UV light like scorpions, and that they're not technically crabs. But today I just want to focus on the properties of their blood for the way that it intersects with medicine, and my special interest is medical history. So first things first, the most striking thing about horseshoe crab blood is that it's bright blue. I mean bright blue. Well, to be fair, when it's inside of their bodies, it's a clear to pale whitish, but when their blood gets exposed to air, it does become this shockingly blue color. Why is their blood blue when our blood is red? This is because their blood uses a copper-based molecule called hemocyanin that turns the blood blue when exposed to air. Notice the word cyan in the word hemocyanin, just like blue ink in a printer. You can also think of the way that copper items start to get this bluish patina on them as they age over time. In contrast, our blood uses an iron-rich protein, which only, boringly, turns our blood brighter red when exposed to air. The second really interesting thing about horseshoe crabs is that their blood has saved innumerable human lives. Their blood has these very reactive immune cells in it that when they sense foreign or invading bacteria, they immediately start to clot around it to seal it off from attacking the rest of the body. It's actually a really cool biological defense mechanism. But because of this awesome feature, scientists have been using horseshoe crab blood in vaccine quality testing since the 1970s. If the immune-sensitive component of their blood reacts with something in the vaccine, it will turn this cloudy or clotted color. Thus, horseshoe crab blood has actually helped ensure that when humans are getting vaccinated, we're not also getting injected with things that can make us really sick or even kill us. Horseshoe crabs have also saved many rabbit lives by offering an alternative for these cute test subjects in vaccine quality testing. But don't tell Mary Toff, she's out for the rabbits. Due to their use in this type of testing, over 1 million horseshoe crabs are rounded up and have their blood harvested in the United States alone each year. A portion of the blood is collected. From what I've read, that runs about 30 to 50% of the blood, which does strike me as a lot, and then they are generally returned to the ocean within a couple of days. The intent is for this to be a catch and release system, but it's not perfect and it doesn't always go well, and the mortality rate for the horseshoe crabs does run a notable 10 to 30%. This arduous process of catching the crabs, collecting their blood, and then releasing them back to the ocean is what makes horseshoe crab blood so valuable. In fact, it clocks in at about $60,000 per gallon, earning it the spot of the third most valuable liquid on the planet. It's dwarfed by king cobra and scorpion venom, but is also 3 times as costly as human insulin. Horseshoe crab mortality that occurs as a result of the blood harvesting process has absolutely decreased horseshoe crab populations in the wild. This has a greater effect than you might think because horseshoe crabs are integral to coastal ecosystems. Horseshoe crab eggs, and a single crab can lay about 4,000 eggs in a sitting, are a crucial food source to the endangered red-knot bird. These birds complete one of the longest known migrations on the planet, and one species goes from the southern tip of Argentina all the way up to the Arctic and back. They make stops along the way, fueling up where horseshoe crabs breed, so the decline in horseshoe crab population has also hit the red knot population hard. Recognition of the ecological impacts of horseshoe crab use has led scientists to develop an alternative, a synthetic compound that could be substituted for what the horseshoe crab blood does in our vaccine testing. Unfortunately, the United States was definitely one of the slower countries to embrace this alternative, mostly due to the lucrative nature of horseshoe crab blood. Thanks, capitalism. In May of 2025, US Pharmacopoeia, a nonprofit that helps ensure US drug quality, finally gave us the official okay to go ahead and use this alternative compound. So very soon, horseshoe crabs should no longer need to suffer for human gain. Gotta love a happy ending.